Hello and welcome back to Barkland Labs on this fine Friday afternoon. I want to record a quick video to show you about the Microrocket Lab. This is your Microrocket. It's a little bit of a pipette bulb, just like this one right here, that you're going to just go ahead and take your scissors and snip off the end of it. You want to leave about that much of the end, and you will see why in just a bit. Second thing you're going to want to do to this pipette bulb is you're going to want to put some marks on it. I put one long mark kind of right on the bottom there, and then you'll notice I put 1, 2, 3, 4, 5 marks all the way up the top. The idea is if you put that mark, that's where your water line is eventually going to be. You'll see what I mean by that in a bit. And then the 5 marks above it are going to separate into 6 different compartments. That's where you're going to be storing some hydrogen and oxygen gas. So, what do we got here? We've got some dihydrogen monoxide. In case you don't know what that is, ask Tommy or Seb or Joaquin or Casey or Jordan. They can fill you in on that. We've got some dihydrogen monoxide. We've got some hydrogen peroxide. We've got manganese dioxide. We've got zinc. And we've got some hydrochloric acid. As far as safety, hydrochloric acid is definitely the thing you want to be most careful with in terms of not touching. You don't need to use gloves on this. It's not a terrible idea. I will have those available. But as long as you're being careful, you should be just fine. Manganese dioxide, you definitely want to avoid inhaling any of this as well. That can be a little bit nasty if you do that. So no inhalation of manganese dioxide. And then you've got a couple of test tubes. Another safety thing is both myself and some of your fellow students were doing some glass bending or glass pulling really to make these things, which are part of our gas generating tubes. So you are going to put some zinc into one container. Notice that I put that into the container labeled H2, hydrogen gas. Hydrogen is diatomic. And then you are going to put some manganese dioxide into the scooper. You put some manganese dioxide, it's just this black powder, you can see it there, into the one that's labeled O2. Once again, another diatomic gas. These are going to be what you use to generate gas for your little Microrocket. I'll let you look at the quantities of how much you add of all that stuff to your test tubes from your lab handout. But what you are ultimately going to do is you're going to add some hydrochloric acid, HCl, not HCI, to the zinc metal. And there we go. And then you're going to add some hydrogen peroxide, H2O2, which I've got in this container right here, H2O2, to the manganese dioxide. I'm going to wait a bit on that because I want to point something out. This is the one that I just added this right here is the one I just added the hydrochloric acid to zinc. You notice it looks a little bit cloudy. You might be able to see some of the bubbles. This is one that I did maybe 10-15 minutes ago. I don't know how much you can tell. Sorry for my terrible camera work. There's a lot of bubbles being given off by that right now. So if you wait over time, this reaction kind of ramps up. What it's actually giving off is hydrogen gas. And the purpose of this stopper with the glass tubing is to kind of focus that gas into a thin stream. So take your dihydrogen monoxide, and I might have you guys do this with a coffee can. It's probably a little bit easier. What you need to do is you need to get a pipette that looks something like this. Should be completely filled with water. You're going to use water displacement. Notice I'm going to slide this up here. You're going to use water displacement by putting this on top of the hydrogen gas tube, and you should notice that we've got a whole bunch of bubbles coming up there, and you can see now we filled one chamber with gas. We filled the hydrogen gas goes slower than the oxygen, actually, even though maybe it looks like it's going fast. Now we've got 2 full. I'll let it go all the way to a third one full here. I'll put it close to the camera so you can see what I mean. You want to make sure you remove it relatively quickly, and if I hold that close to the camera, you can see that those top 3 compartments there are now looking like they're empty, but they're not empty. They're actually filled with hydrogen gas. The purpose of putting those markings on there, you should try and space them out as evenly as possible, is to mark where I have 3 different equal volumes of that gas. Well, now I want to add some oxygen gas. So I'm going to take my H2O2, which is right here, and when you add H2O2 to manganese dioxide, so I'll move back a little bit, you see a pretty vigorous reaction down there. The manganese dioxide is reacting with it to give off hydrogen gas. It's actually allowing the H2O2, the hydrogen peroxide, to break down really fast. So you got to be careful here. This goes really quickly. Watch what's going on here. I'm going to shoot to get the gas level right there at the bottom of the pipette. So there it goes, and there we go. Yeah, that's actually good right there. So let's move this out of the way. You should notice that now the gas level is down to right there. So what that means is I've got 3 parts hydrogen and 3 parts oxygen. What that means is I've got equal volumes of each of those gases trapped in this little chamber right now. The purpose of that water is to basically be a little sealant or a seal to protect or to keep that hydrogen and oxygen in there. So be really careful not to flip it upside down, because hydrogen particularly will escape there. Oxygen will escape as well, but because the hydrogen is less dense than the air around it. So that brings us to the launcher right here. I'm going to tilt this down a bit. I'll talk about how I built this in just a bit. I'm going to, just so I don't have to hold this, I'm going to go ahead and launch it, and then I'll explain what we got going on. So I'm going to put it on there, and here we go. Okay, so that was a successful launch. I'm going to go get Microrocket. That just launched off of our little launching platform here. What we've got here is something called a piezo electric igniter. I built these last year from scratch. This, when you press that, it generates a very small voltage electricity. And if you look at those 2 wires, I don't know if you can see that. Let's try that a couple more times. It's probably out of focus. You might be able to see that there's a little zap of electricity. Let's move them apart a bit more. Yeah, you may or may not be able to see that. There's a little zap of electricity between those. And yes, you can shock somebody with it. Let's try and minimize the amount of shocking we've got going on. But you can shock somebody. And the purpose of doing that is you're going to put that inside your, you're going to basically put those 2 wires inside of your Microrocket. You need to leave a gap, because if there's no gap between those between these 2 wires right here, then the electricity takes the path of least resistance, which is to not travel through the air at all. But when there is a little bit of a gap, let's try that again. Once again, I can't tell if you can see it or not. I'm going to turn the lights off real quick. Okay. So, yeah, there you can see that now. Perfect. So you want that's called an arc. You want that arc to occur inside of your pipette bulb. That's going to cause the hydrogen and oxygen gases to start their reaction. It's kind of like using the striker, the flint striker, to start your Bunsen burner burning, and that will shoot away somewhere. And what you are ultimately going to be doing is you're going to test different proportions of hydrogen gas to oxygen gas. So you'll try 2 parts hydrogen to 4 parts oxygen. You'll try 1 part hydrogen to 5 parts oxygen, and so on, and see which one gives you the furthest launch. Now, a couple control variables to think about. This is launcher 8. You always want to make sure you're using the same launcher. Another control variable is, notice that I've got this at a certain angle right now. If I bend this, obviously that's going to make that rocket go a different direction. So I'm hoping we can finish this all in one day, so no other classes mess with your launcher, but you want to make sure you're launching from the exact same angle. A 45-degree angle gives you the best launch, so shoot for as close to 45 degrees as you can. And then measure how far that rocket goes with a meter stick. And you're obviously going to do multiple trials. And we're going to use that to talk about how we balance chemical formulas and what kind of the optimal balanced formula for hydrogen gas reacting with oxygen gas is. I hope you all have a lovely President's Weekend, and I will see you back here on Wednesday.